Okay, so we're going to go back and revisit some things on worksheet 2, and then we're going to start section 3.2. But on worksheet 2, we talked about exponential growth and decay and what the graphs look like. If we had a b value greater than 1, it was doing this. And because anything to the 0 power is 1, it went through 0, 1. The same was true of the graph going through 0, 1 if it had a decay, but what's in the parenthesis here, the value of b was less than 1, but greater than 0. So we're going to review that by doing this question. You don't have this, so this is one of our warm-ups today. Give me 3 ordered pairs. If I put in a 0, 1/2 to the 0 would be 1. Okay, what else? 5. If I put in a 5, what would I have? It would be 1/32. 2 to the 5th, yes, guys? I'd have 1/2 to the 5th. That's pretty little. Let's try something else. Okay, 1 would be what? 1/2. What would be a nice one? -1, Andrew says, because -1 would flip it over and give us, so -2 would also be good. It would become 4. Okay, 0, 1, 1, 1/2. But at -1, it's at 2. At -2, it's at 4. So this is the shape. Remember, Thursday's quiz is no calculator. Okay, so I'm not so worried about this, but fill these in real fast for me. Any exponential growth or decay, the domain is, the range is with a soft parenthesis, right? Intercept, it only has 1. Okay, asymptote, y = 0, or you could write x-axis and I'd take it. I don't think end behavior is on the quiz, so I'm going to skip it. And this one is always decreasing, okay? This is what's on your little yellow sheet. Everybody has this little strip of application formulas, okay? You can use that on the quiz. You have to set up, but you do not have to solve applications on Thursday's quiz. Does that make sense? It's no calculator. So the big thing, do you notice this word is underlined here? We had a little bit of discussion about this on Friday. But if a question just says growing exponentially or decaying, you don't use these. This is if the question says continuous. Then you use these. Okay? You do the question on the quiz, I think, has an either exponential growth or decay, and then it has one compound interest one. We did this question. Is this on 2? I hope so. Yeah. Is it on 2B? 2A. Okay. So this is 2A. We messed this question up. Did anybody catch me on Friday? I was rushing through this, and it says compare the balance after 10 years of a $10,000 investment earning 8.5% interest compounded continuously to the same investment compounded quarterly. Okay, so quarterly we did 5,000 times 1 plus 0.085. Everybody get where we got that decimal? Why did we divide by 4? And we put the 4 up here, right? Goes both places. And then it was for 10 years. So let's do the continuous part just to revisit that. And because the question actually said, and I skipped it, to compare the two. All right, so what would we do if we were doing this continuously one? Yes, PERT, which means what? For this question, 5,000. E to what power? 0.085 times 10. So remember where I said to use second ln. So we had 5,000 second ln to the 0.085 times 10. And we get a number a little bit more than this one. So continuous interest gets you a little more money after 10 years than compounded quarterly, okay? If you did compounded monthly or daily, it gets even closer to continuous. All right, does that revisit those two formulas a little bit for you? We did this question. The other one I kind of wanted to do together is this. You don't have, I'm not sure if you have this. Is there an exit ticket on the back of 2B? I think this is one of the exit ticket questions, which probably leaves you little of no room to do it, but let's fake this, okay? The number of bacteria growing exponentially. How many bacteria were there at 7 p.m.? So if we're going to call this our original amount of 100, it was growing exponentially by some rate that we don't know. For how long? 2 hours. And it became 4,000. What would we do first to solve and find the rate? Divide by 100, which is 40 on a good day, I think. Now, whatever this number was, we would do what? Now, we all know we're going to square root here, but what if it had been 6 hours? What would we have done? 6th root, or do you remember how we talked about that? The 1/6 power. So we could do both sides here to the 1/2 power. And yes, that's a square root, and that's fine. But everybody understands that the 1/2 power will get rid of the squared? Okay. So we have 1 plus r equals, you can type square root of 40 or 40 to the 1/2 power, and you don't need parentheses on your calculator. I just do because I don't have it in the right mode. You get the same answer. Everybody good? Okay. So now we have 6 point, what do we do next? If we subtract 1, so it's growing at 5.32. Is that a rate? That's the rate. In just 2 hours, guys, did that grow 40 times as big? 100% growth would be from 100 to 200, right? So this is like 532% is what it is. Okay. All right, but back to the question. We just want to go back and figure out at 7 p.m. So if we started at 100, 1 plus 5.32, how many hours until we want to figure out what we have? If we started from 2 p.m., 5 hours. So try that. I got 1011484 or 485. Is that pretty close to this one, I think? I think if we had done more decimals, we would have probably got their answer. No one's getting that? Did you not get that, Fatih? Or you did? Okay. What? It depends how many decimals you use, maybe. I don't know. Okay. 100 times. Oh, I put 324. That's why. Yep. I did the whole thing. Yep. If we had typed square root of 40, to the 5th. 1011928, is that what they had? 929? Okay, so they just did the longer decimal. All right, good thinking here. Okay, let's one more off that little exit ticket. What ordered pair is this going through? 0, 2. Can we tell anything else? Maybe it's going through 6, -1, 6. I can't really tell. But which ones would give us a 0, 2 even? F, G, H, or J? Any of those going to, if you put in a 0, get out a 2? Three to the 0 is what? 3 to the 0 is 1 times 2 is 2, right? 1/3 to the 0 is 1 times 2 is 2. But these two, that would give me 3, right? Okay, you're scaring me because no one was. All right, so now, well, if we're down to those two, which one is it? Why is it G? It's decay, yes. Better? Okay. That would be a great no calculator question. It's not on the quiz, but you could handle that without a calculator, I hope. Maybe, eventually. All right, one more thing. 30 seconds. What are the transformations going on here? This is actually off your homework. This is what happened from here to here. Down 3. This one, left 4, down 3. What about this one? Reflect over X and vertical stretch by 2. But okay, this one, right 2 and up 5. Oh, I don't think we want to talk about that one. Okay. Yeah, it's reflect Y, but it's first, you'd have to go X minus 3. Should be right 3 and then reflect. Yeah, we don't want to go there. Okay. Do you understand that those would change the intercepts depending if it's, and they would change the asymptote, yes? Okay. I'm going to skip back to today's stuff. All right. One quick, so today we're going to talk about graphing and analyzing log functions, rewriting from log to exponent, and evaluating without a calculator. This is also a warm-up because this did not go well and it's on the quiz on Thursday without a calculator. Okay. This is a plus 2 over a times a minus 1. Oh, really? We're doing this jumpy thing again. Does anybody remember how I ever fixed that? I feel like I had to close it, but common denominator, a times a minus 1. And remember, you're doing that times everything. Okay, so all of this will divide all of this out. So left on the left is a plus 2. This term becomes a times a minus 1. This term, 1a. All right, so now I have a plus 2 equals a squared minus a plus a, which is just a squared. If I get it equal to 0, I'll have a squared minus a minus 2, which factors a minus plus 1 minus 2. Okay, didn't like me going back and trying to write that on there because it jumped it in. Yep, pretend that says plus. So we get -1 and +2. Both work or not? Yes. What are the restrictions? A cannot equal 0 or +1. All right. That didn't go very well. Some of you left that section blank on the last quiz. All right, today, logarithm. No, it was at the bottom of the 3rd page of the quiz. Functions that pass the horizontal line test are said to be one-to-one and have inverses that are also functions. So our exponential growth and decay functions have inverses. Their inverses are called logarithm functions, okay? So we need to understand that they are inverses of each other. I have a video for your entertainment. 3 minutes, guys. Oh, am I going to get in trouble for recording this? It's a TED Talk. I don't. Okay, that's because I put it in the. Because I taught that course first.
Logarithm. Let's take the base number b and raise it to a power like 2 to the 3rd power and have it equal a number n. We get an exponential equation b raised to the p power. In our example, that'd be 2 raised to the power.
This really
8.
will help.
The exponent of p is set. Times will be written log base b, the number equals p to the power. This is starting to sound a bit confusing with all the variables. So let's show this with an example. What is the value of log base 10 of 10,000? The same question could be asked. 10 raised to what power is 10,000? And 10 to the 4th is 10,000. So log base 10 must equal 4. This example can also be very simply classified. Log base 10 is so frequently in classes that it has the honor of having this button on most calculators. If the calculator will figure out logs, why study them? Quick reminder, the log button only computes logarithms of base 10. What if you want to go into computer science and need to understand base 2? So what is log base 2 of 64? In other words, 2 raised to what power is 64? Well, fingers, 2, 4, 8, 16, 32, 64. So log base 2 must equal. So what does this have to do? My eyes that is well, it leads us into an interesting use of logarithm chemistry, finding the pH of water samples. pH tells us how acidic or basic a sample is, can be calculated with the formula equals negative log base 10 of the hydrogen ion concentration, or H+. We can find the pH of a water sample with hydrogen ion concentration of 0.0000000 and 0.00000000398. Quickly on a calculator, punch negative log of each of those numbers. And you'll see the pH are 7.4 and 8.4. Since the tears in our eyes have a pH of about 7.4, the H+ concentration of 0.70398 will feel nice in your eye, but the pH of 8.4 will make you feel H red. It's easy to remember logarithms. Log base b of some number n
guys,
equals p.
This is what you need to do.
Now we know logarithms are very powerful. Really small or large numbers, logarithms.
Is it enough? What? Jeez. What did I do? Trying to do that. Okay. Okay, guys. So this is what I have a slide that says, but this is what yours says. My suggestion is that you use the letters that he used because I really think it's helpful that B is the base, P is the power, and N is the number. So it's base b, the answer to the logarithm is the power. So if I ask what is log base 5 of 125, anybody know the answer to that? It's 3, yes, because it means 5 to what power is 125. That's what you have to be able to do for the quiz without a calculator. Okay? All right, so let's start here. Can anybody rewrite this one? Do you have this one on your notes? Okay. Go ahead. Patrick? Okay. So this one? That's not going to work, is it? There's no going back and fixing things with this weird mode it's in. Okay? There's a question that asks you to rewrite one of each on the quiz. So what's going on here? Log base A of B, because the answer, remember, is always the exponent. Okay? Log. Okay, there's a question like that. It's not a number that big. Okay, but let me go back and do this one. Probably not. It's just good practice. That says 25. I pretend it says 25. Okay. Log base 5 of 125th. -2. Because this is 5 squared, and what put it in the denominator was a negative. Yes? You can do that? Okay. We do need to go back and talk about this. What does this say right here? You can only take the log of a positive number. You can get a negative answer. We just talked about that. But there is no way to take the log base 5 of -5. Okay? That's saying 5 to what power will make something -5? Can you change a positive to a negative by an exponent power? No. Okay? So on the quiz, this question quite likely does appear, and you have to say, not possible, non-real solution. Be very careful. People write that as 0. 0 with a slash. People do that all the time and call it 0. No, this is the question. What is this saying? What's the answer to that? That is 0, right? 7 to the 0 power is 1. And that's on the quiz too. So, because I give the easy ones, okay? So here's the basics. B to the 0 is 1. So the log base B of 1 is always 0. Log base B of B. So if it said log base 2 of 2, the answer would be 1. Okay? Etc. We also, everybody knows that, did you need me to go back? Are they on your sheet? Are they not written? What's happening? Okay. When we don't use a base, when they just write log and there's no base, it's understood to be a 10. Okay. And it's called a common log. And that's the same properties. And remember we talked about E on Friday, Euler's number? Occurs in nature. Do you remember what it's about? 2.7. Remember, pi is a little more than 3. E is a little less than 3. Okay. They use, instead of writing log base E, they call it ln, or natural log. Okay. So this is what you need to know from there, that the natural log base E, I can. Okay. Cancel each other out here. All right. So let's practice these. Oh, these are the ones you do have, yes? Okay, those are your properties. If you take the log of a negative number on your calculator, you will get non-real answer, because they can be done with imaginaries. That's a whole other world. Okay, so this is an example of what could be on the quiz. This is saying 5 to what power is 1/25th? Is everybody okay? 5 to what power? Well, this is 1 over 5 squared, and what put it down there was a power of -2, right? So the answer is -2. Okay, what's this one? 3 to some power equals, what power is that? 1/2. Everybody good? Square root is 1/2. All right. Yes, ln and e undo each other. So this is, if you wrote this out, yes, yeah, it would be like 1 to the 7th. It's just 7, yeah. That there's a base e here, so it's saying e to what power equals e to the 7th. So what goes in that box is just 7, okay, if you were thinking about it that way. All right, so this is 5. Can I just keep going, or do you need me to talk about how to write that back into the other form and so on? This one, you want me to talk about it? Okay, this is currently an exponent, right? So this is the base, this is the power, equals the number. If we rewrote that as a log, it would say what? Log base e of n equals the power, which is ln of 5. Okay, what is log base e really? Just means ln, right? So now you have this. So this has to be 5. Does that help? Okay, so this also undoes each other and you just get 13. Am I okay? Now to keep going. All right. What's this one? 7 to what power is 7? Okay. This is a log base 10, so they undo each other and you would have 5x. I didn't put any with a variable on the quiz. What does that even say? Oh, okay, so it says, I think it's supposed to say 3 log base 3 of 2. So yes, these undo each other and you just get 2. Okay, what's this one? 6 to what power is 36 would be 2. Anybody know what this one is? Yes, it's log base 3. All right. E and ln undo each other. Yeah, x squared, I guess, is what they're looking for. That's just weird. Not on the quiz. Okay. I just have extra practice. Is there any of these you want me to go over? This is the icky one and it's not on the quiz. This says 16 to what power equals the square root of 2? Okay, if I wrote this, what is this as a power of 2? 2 times 2 is 4, times 2 is 8, times 2 is 16. So this is 2 to the 4th equals 2 to the what? 1/2 is the square root. So 4 times something equals a half. One-eighth. You'd have to divide both sides by 4, right? To get that little box by itself. So it's 1/2 times 1/4, which is 1/8. That's not on the quiz. Is everybody okay with that? Yeah. Okay. Log base 10. This is 4. Yeah, that's a calculator question. I don't even know what that is. Yeah, Negative 0? What's this one? Yeah. Because you can't, this would just be 3. There is, I don't know what that's even all about. Which of these require a calculator? This one would take a calculator, right? And this one would take a calculator. This would be 4. Anybody know what this would be? Negative 3. Because it's in the denominator. Okay? This is really ln of e to the negative 3 because that's what puts it in the denominator. Do you kind of remember this whole, we're going to talk about tomorrow, the exponent moves out in front, so this becomes negative 3 times ln of e, and then this is just 1. That's a property we'll talk about tomorrow. All right, guys, I want to get to the graphs. I'm actually going to skip these applications. If we have time, we'll come back to it. All right. The inverse of an exponential is a logarithm. So that means what about the graph? What does it mean when we have an inverse? It's reflected over the line y equals x, yes? So the inverse of an exponential growth should look like that. What is the inverse of an exponential decay going to look like? That was horrible. It's going to be, how's that? Something like that. All right. You want me to go back over that one? Okay. If I had an exponential decay like this, okay, what's this ordered pair right here? 0, 1, yes, 0, 1. So the inverse would be at 1, 0. I can't draw on this, okay. And if this was, say, 1, 1/2, it would become 1/2, 1, okay. If this point over here was negative 1, 2, it would become 2, negative 1, okay. So it would look like this. They should reflect across that line. Is that better explanation as well as I can do with my goofy smart thing it's doing? All right. Again, the questions on the quiz are domain, range, intercept, and asymptote. Okay? Domain, range, intercept, and asymptote. You have to be able to graph a log question. The easiest way to graph a log question is to rewrite it as an exponent and then do what to all the ordered pairs? Flip them. So if I ask you log base 2 of x equals y, rewrite that, and what would that say? 2 to the y equals x. Okay? So you could put in y values instead, right? 2 to the 0 would be 1, 2 to the 1 would be 2, 2 to the negative 1 would be 1/2. Yeah, that's a hot mess. Okay? All right. Transformations, it just says, remember that horizontal translations are dependent on the constant inside the parentheses. Vertical translations are outside the parentheses. So if you're doing a log thing and it says to slide it 2 to the right, you have to do in here and make sure you put the parentheses, okay? If it said to go down 2, you can't write this, guys. You need to do this, okay, to tell me that it's not in the parentheses. That's what it's trying to make sure you know. All right, can anybody tell what this would do? Then we'll actually graph some, but what would this do? Inside a +4 would be what? Left 4, okay? First of all, the exponent out front would be, or the negative out front, reflect over the x, and then, oh, they didn't put the parentheses. I'm hating on them. It is down 5. Okay, this one is vertical stretch and left 2. All right. Here's the one that's done on your sheet. It's 6 to the x. Okay. Well, no, we're supposed to be graphing this. Log base 6 of x. It's the inverse of 6 to the x. So if I rewrite this, it says 6 to the y equals x. So you can put in y values if you want and get out x's, right? So 6 to the 0 would be 6 to the 1 would be 6 squared. Yeah, I don't think that's going to fit on a graph paper. 6 to the negative 1, 1 6. Are we good? So then we could graph those. So the graph is this one down here. So its domain is 0 to infinity. Guys, what happens to the domain and range when we do inverse? Yes, so on all our exponential growth, remember it was domain was negative infinity to infinity and range was 0 to infinity. So now what's going to happen? Yes, they're going to flip because all the x's and y values have just flipped. So now domain is 0 to infinity and range is all real numbers. And instead of 0, 1, the intercept is at 1, 0. And instead of the asymptote was the y equals 0 or the x-axis, it's now x equals 0 or the y-axis. Are we good? All right, so let's try this. This is a quiz question. This exact question on somebody's quiz, either version A or B. Okay? How do you want to practice this as a class? 3 to the y equals x. Okay? Now what do you want to do then? Plug in y's. We can rewrite it, but then you got to remember to switch all the ordered pairs back around. Okay? If you just say I'm going to put in 1 for y, this will become what? Okay? 0? Negative 1? Okay? 3 ordered pairs is what you have to have for the quiz. Right, Fatih? You awake? So 3, 1, 1, 0. I'm doing my best to make these land where they're supposed to. Negative 1, 1/3. That's not right. What did I do? Those were y values. This one is wrong. 1/3, negative 1 should be down here, right? Okay, sorry. Now do you see what I did? I was supposed to go over 1/3 and down 1. Okay. So I'm never going to hit those. I'm just going to do a little bit and see if it slides to the right spot here. Oh, I didn't do too bad. I get an A for the day. Okay. Now, domain? No. Domain is left to right. Okay. Range, bottom to top. What am I doing next? Intercept? 1, 0. Asymptote? Yes, it's x equals 0 or the y-axis. Increasing or decreasing? It's increasing. End behavior is not on the quiz, but what is it doing? As x approaches 0, y approaches negative infinity. X doesn't ever go beyond 0. And then as x approaches infinity on the right, y is approaching infinity. Yeah, that's supposed to say negative infinity right there. All right, what's this one supposed to do? 2 things. Reflect over the x and right 2. Okay, So this ordered pair down here that was at -1 is now at 1/3 1, but moved to the right 2 is somewhere over. Yep, that's not working. What's it supposed to be at? Okay, it was at 1/3 -1. So then I flipped it over and became at 1/3 1. So it's now 2 1/3 1. Jeez, sliding further than I thought it was. I don't know if I can click on it and move it. Oh, I can move that. Okay. Anyway, that's not good. This point that was at 3, what was it at? 3, oh, it was supposed to be at 3 1. Okay, because it wasn't graphed right the first time because I can't plot anything today. Oh, yeah, just a minute ago. Okay. It was at 3 1. When I flip it over, it's at 3 -1, and then I slide it 2 to the right. Should be. Ugh. Okay, and this one was at 0 1. It's still at 0 1, but I slid it 2 to the right. So it should be something like that. Anything? Anybody? But it actually, that's not good because what should it not cross? Yes. Because the asymptote was the y-axis and we slid to the right too. That's not far enough. I give up. Okay, the asymptote should be, yep, at, oh my gosh. It's at 2. Anyway, moving on. Yeah, the scales are ugly. We just got applications left. And all the application guys, all the applications are just typing. Just rearranging and typing, okay? So what you need to be working on, you got the check sheet at the door, okay? Be working on 3.2. Everybody good? Okay. 3.2 you picked up at the door. It's on the homework check sheet you picked up at the door. Right, Sam? You've got one at the door?